Okay, so get this right. Today we are diving into AI. And not just any AI stuff. This is big, trust me. We're talking about the possibility that different AIs, like ones trained on totally different stuff, might be starting to see the world in the same way. Wild, right?
Yeah, it's a fascinating idea. It's like they're coming up with their own language to understand everything.
Seriously, imagine if, say, your chatbot could actually look at a picture the way an image AI does. That's the kind of thing we're getting into. And there's this new research from MIT, right? The Platonic representation hypothesis. Sounds intense and it's going to get kind of weird.
Yeah, Platonic representation hypothesis. It's a mouthful for sure. Basically, it's saying that as these AI models get more and more advanced, they might actually be homing in on one ultimate way to represent information.
Hold on. So instead of each AI having its own way of understanding, they're all starting to agree on one single blueprint.
Exactly. And the research behind it is pretty wild. Take, for example, model stitching. Researchers are literally taking parts of different AI models and just sticking them together.
Whoa, hold up. So they're Frankensteining these AIs.
Kind of. And the crazy thing is, these combined models often work really well, which suggests there's something fundamental about how these models understand information, even if they were trained on completely different data.
That's nuts. So it's like they're speaking the same language, even though we never taught them one.
Yeah, precisely. And the MIT research gives us a few reasons why this might be happening.
Okay, hit me. What's clue number one in this AI mystery?
Well, one idea is this focus on task generality. Basically, we're moving away from AIs that just do one specific thing. Now it's all about models that can do it all. Write text, translate languages, come up with stories, answer questions, you name it all in one package.
So, like those multi-tools you keep on a keychain, except instead of a tiny screwdriver, it's an AI that can write you a poem.
Uh-huh. That's a great way to put it. And just like that multi-tool needs a specific design, an AI needs a specific way to represent information to handle all those different tasks.
Got it. So the more we ask of these AIs, the more they're forced to find a single, efficient way to make sense of everything.
Exactly. Which brings us to the second piece of this puzzle, the capacity hypothesis.
All right, now we're talking. Tell me more.
So the capacity hypothesis basically suggests that those bigger, more complex models, the ones with more brain power, they're more likely to stumble upon these optimal ways of representing information. Think of it like searching for something tiny, a needle in a haystack. The bigger your detector, the better your chances of finding it.
So bigger models are like those industrial strength magnets, the
Yeah.
ones that pick up cars. Okay, that makes sense. But how does this capacity thing actually work? Is it more data or...
It's a bit of both, really. Larger models can just store and process more, letting them learn more complex patterns and connections. They're also way better at taking what they've learned and applying it to totally new situations.
Makes sense. But wait, there was one more piece of this puzzle, right? Multitask scaling. What's that all about?
Oh, right, the multitask scaling hypothesis. Basically, this one says that the more tasks a model is trained on, the more pressure there is to find one super efficient representation that just works for everything.
So instead of different parts of the AI handling different things, it's just better to have one brain that does it all.
Exactly. Imagine a library where every book is in a different language, follows different rules,
Yeah.
total chaos, right? But what if there was one system that worked for every book no matter what? That would make things much more organized.
Okay, I see what you mean. So instead of separate shelves in their brains for every task, these AIs are figuring out how to put everything in one place, and that just happens to be super effective.
You got it. It's like they're figuring out the universal library system for understanding, well, everything.
Wow. That's incredible. But hold on, before we go too far down that road, let's get back to those stitched together AIs for a sec. Is there solid evidence that these different models are really starting to think alike?
Oh yeah, there's definitely evidence. One crazy example is this thing called Rosetta Stone neurons. Researchers found that certain neurons in totally different vision models, trained separately, right, they'd fire in the exact same way when they saw similar patterns.
Wait, slow down. Rosetta Stone neurons, you're going to have to explain that one like I'm 5.
Okay, so imagine two people, yeah. They speak totally different languages, never even heard of each other's language, but then you find out they both use the exact same word for, say, tree.
Whoa, okay. So these AI neurons, it's like they're figuring out the same words for what they see, even though we never gave them a dictionary?
Exactly. Like they're tapping into some fundamental level of how vision works. A universal visual language almost. And it gets even weirder.
All right, now you got to tell me. Weird or how?
So this whole convergence thing, it's not just with vision AIs. They're finding this alignment
Hmm.
between language models, like the things that power chat bots, and those image-based models too.
Hold on. So you're saying the better a chatbot gets at like talking and understanding language, the more it starts seeing the world like an AI that was trained on fiction.
Bingo. It's more evidence that these different AIs, they're all kind of heading towards the same understanding of reality, like puzzle pieces falling into place.
Okay, I think I'm starting to get the bigger picture here, and honestly, it's kind of blowing my mind. But before we get too far out there, gotta ask, if these AI models are becoming more alike, does that mean they're becoming more like us too? Are we talking like AI that thinks like humans?
That is the million-dollar question, right?
Yeah.
And that's where it gets really interesting because there's more and more evidence that these AI representations, they're not just converging with each other. They might be aligning with how our brains work too.
Wait, for real? Like matching up with brain scans and all that?
Yep. Researchers have been comparing how AI models activate with how our brains light up. And it's kind of uncanny. Show them the same image, and boom, similar areas light up in the AI and the brain.
So it's not just that we're building machines that act like us, maybe they're actually starting to think like us too.
It's getting harder and harder to ignore that possibility. And that just opens up a whole new can of worms. What happens if we make these models even bigger, more complex? Will they, like, zoom past human intelligence? Or is this leading to some kind of weird symbiotic relationship between us and machines?
Okay. Before we go full on existential crisis here, let's take a breather. We've got these AI models. Maybe they're on the same wavelength, maybe even thinking a bit like us. But why does it matter? What's the big deal for the average person listening to this right now?
That's a great question. One of the most exciting possibilities is how this could totally revolutionize the way we use technology. Imagine controlling your computer with your mind, or having AI that gets what you need before you even have to say it.
Okay, now that sounds like something out of a movie, but I'm listening.
It might sound far out, but it might not be as impossible as we think. More realistically, this could mean AI that's way more efficient, more reliable. AI that learns faster, adapts better, and is just generally more helpful.
So we're talking like self-driving cars that actually work, medicine that's personalized just for you, all because AI is starting to think more like us?
Exactly. And that's not even touching on fields like, robotics, art, even education. Imagine AI teachers that adapt to how you learn best, or AI artists that collaborate with humans to create totally new art forms.
It's like we're not just talking about AI getting a little better. It's like a whole new ball game, right?
Sure.
How we use tech, even how we understand ourselves.
No, yeah, absolutely. This isn't just about, you know, building a better chatbot. It's about intelligence itself. Like, what is it? If all these AIs for designs trained on different stuff, if they're all coming up with similar answers, well, maybe there is some optimal way to process information, some kind of like universal intelligence.
Whoa. Okay. Now we're getting deep. But I gotta say, it's kind of mind blowing. We're talking about like cracking the code of intelligence itself, even if it's, AI doing the cracking.
It really makes you think, like, if there is this universal intelligence thing, does that mean there's one right way to see the world?
And if AI is the one finding that right way, what does that mean for us, with all our like human baggage and stuff?
It's humbling, for sure. But also, it's a crazy exciting time, right? We're seeing a new kind of intelligence being born, and it's changing how we understand ourselves, the whole universe, everything.
Yeah, no, it's a lot to take in. So if you had to leave our listeners with one last thought, like the big takeaway from all this AI convergence stuff, what would it be?
Well, if these AIs really are tapping into something universal, something bigger than all of us, who knows what they're capable of, right?
Yeah.
Could they figure out things about the universe that we've never even thought to ask? Could they be the key to solving, like climate change, poverty, all those huge problems? It's exciting, a little scary too.
Yeah.
The possibilities are kind of endless.
Gives a whole new meaning to the future is now. Well, that's it for today's deep dive, everyone. We went from stitching together AIs to the universal intelligence, so yeah, we covered some ground. I don't know about you, but I need a minute to process all this. Be sure to catch us next time, same place, for another deep dive into the world of science and tech. Until then, stay curious.